Hi everyone. This is example 3 from chapter 13 in your Unit 3 student packet. So it says, in 2010, ACT reported that the national college freshman to sophomore retention rate held steady at 74% over the previous several years. Part A, if we take random samples of 400 freshmen, can we use a normal model to model the sampling distribution? So what this is asking us to do is check to make sure that we have all of the assumptions met for a sampling distribution. So there are 4 big assumptions that need to be met. The first one is that the samples need to be random. Now in this case, they actually say that they're taking random samples of 400 freshmen, so this is satisfied. The next condition is that the sample size cannot be so large that it's more than 10% of the population. So this is called the 10% condition. So first, it doesn't specifically point to this, but we can use our common sense. We know that these samples are 400 freshmen, and we know that there are hundreds of thousands of college freshmen in the United States. So this condition is met. We can say a sample size of 400 is less than 10% of the population size. Now, why would we not want the sample size to be too big? Because typically you would say, don't you want the sample to be as big as you can get it to be? We don't want the samples to be too big because if they are, then we can't guarantee that the individuals within our sample are independent. And that's the third condition that needs to be met. Now this third condition kind of combines 1 and 2. So if the samples are random and the sample size is less than 10% of the population, then for the most part we can say that the individuals within the sample are independent. So since the first 2 are checked, the third one kind of automatically gets checked. And then the fourth condition is the sample big enough? And for proportions, there's a specific way that we calculate this. And we want to make sure for proportions that we have at least 10 successes and at least 10 failures. So when we're counting successes and failures, we can take the sample size and multiply by the proportion, because usually the original proportion given to us is the probability of success. So the number of successes in this case is going to be 400 times 0.74. And that's going to give us 296. Definitely greater than 10. Now the number of failures you can calculate in 2 different ways. You can either take 400 minus this 296, because for proportions you either have success or failure, or you can take 400 times the complement of 0.74. So the failures are going to be, I'll do the complement, 400 times 0.26, which gives us 104, which is also greater than 10. Basically, with this last condition, you want to make sure that if the if the proportion is really low or really high, so you get something like 3% or 98%, then you need to have a sample size that's very large in order to meet this condition of having at least 10 successes and 10 failures. So now that we've met all the assumptions, let's actually figure out what our sampling distribution model is. So remember that the sampling distribution model for proportions is that it's a normal model where the mean is the population proportion and the standard deviation is given by the square root of PQ over N. So in this case, the mean of the sampling distribution is going to be 0.74, our population proportion. And to figure out the standard deviation, we'll take the square root of 0.74, which is P, times Q, which is the complement. So let's take 1 minus 0.74, which is 0.26, and divide by the sample size, which in this case is 400. And when we do that calculation, we get, again, the mean is 0.74 and the standard deviation is 0.022. So we're going to use that mean and standard deviation of the sampling distribution to answer the next three questions. So part C, it says, does a college where 318 of the 400 freshmen return the next year as sophomores have a right to brag that it has an unusually high retention rate? So we're going to calculate a z-score. So first, we need to know what the sample proportion is for this college. So P hat is going to be 318 divided by 400, which is 0.795. Now let's calculate the z-score for this. So remember, we calculate the z-score by taking, in this case, P hat minus the true proportion P divided by the standard deviation. So this is going to be 0.795, our P hat. Subtract the population proportion, which is 0.74, divided by that standard deviation that we found in part B, and we will get a z-score of 2.5. So yes, a z-score of 2.5 is pretty unusual, and so I would say that this college has a right to brag with that sample proportion. Now looking at part D, what is the probability that a school will retain less than 70% of their freshmen? So remember that when we're using a normal model, we can apply the normal distribution. And so we have a distribution command in our calculator called normal CDF. So we use this when we want to figure out a probability. So in this case, we're going to do a normal CDF. And we are looking for the probability that this is less than 70%. So our distribution is going to go from negative infinity, which I'm going to use negative with a bunch of nines, up to an upper bound of 70%. We want to make sure to write that as a decimal of 0.7. And then we're going to use the mean and standard deviation that we found in the sampling distribution model. So that's going to be 0.74 and 0.022. So when you put this in your calculator, you will get 0.0345. So about 3.5% of colleges will retain less than 70% of their freshmen. For part E, it says, what's the probability that the school will retain more than 3/4 of its freshmen? So we're still figuring out a probability with a normal model. So we're going to use normal CDF. But now we're going to go for more than 3/4. 3/4 is 75%. So this is going to go from 75% up to positive infinity. So we'll do 0.75, and I'm going to use a bunch of positive 9s for positive infinity. And then we're using the same mean and standard deviation. Oops. Our mean is 0.74, and standard deviation of the sampling distribution that we found in part B. When we put this in our calculator, we'll get 0.325. So about 32.5% of colleges will retain 3/4 or more of their freshmen.